Well, it has been a very, very long time since I've made any videos about my 12-volt solar shed that I have in my house. I've got one 100-watt grape solar panel sitting in the window there, and this is what it looks like from outside the house. It's a cloudy day today, but if it were a nice bright sunny day, the panel would get about an hour and 45 minutes of direct sunlight on it. And it does pretty good despite being in the window. Unfortunately, I don't have any place to mount a solar panel outside at all. So this is the best I can do. The last time I did any videos on my 12-volt solar shed, I built these two lithium battery banks. Each one is about 840 watt hours. There's 36 cells in each pack. I built these in January, about 9 months ago. I have been using them all summer long to operate a couple of very small DIY lights that I also built. So here's one of the DIY lights that I built that I powered up during the summer with one of the 850 watt hour battery banks. This one was designed to be self-contained, having its own 3S pack mounted in it. I don't use it that way. It's got a variable speed motor switch to control it. It uses for these little LED lights, stick-on lights that you can buy for cars. Here's another one that I used on the other battery bank. This one is not self-contained. It was plugged into the battery bank. Same principle. Has a little variable speed motor switch. The last little DIY light that I built was this one right here. I built this late in 2017. It is completely self-contained using a 3S pack of three 18650s. Again, the variable speed switch. It can put out a lot of light. It's quite handy to have around as an emergency light. So today I was planning to do some experimenting with this lead acid battery that I have. This is an AGM battery I bought on eBay. It was some sort of a replacement battery for something, I don't remember what. But I paid about 15 bucks for this on eBay a few years ago. And it's just a nice little 12-volt battery. It gives you some information on there. I don't know if you can read that. 20 hours. Anyway, I wanted to do some experimenting with that today, but I'm actually bringing it up right now. It was very, very cloudy yesterday, and I couldn't get it fully charged back up. I've been experimenting with some other lights, just some things some DIY things I built. But today I want to try to run this little inverter. It's a 300 watt inverter that I've had for quite a while. I actually have experimented with it, and unfortunately, as soon as you hook it up and turn the inverter on, it starts taking power away. I've got it rigged up to run a little LED light bulb here. It's like a 4-watt bulb, but I don't think this little battery is going to do it. I'd like to be able to run the thing all night long, but I know it's not going to happen. So now I want to just see if I can even hook it up and just turn the inverter on and just run, just let the inverter run, let the fan run, and see if I can even let it run all night long. I don't know if I can. That thing just uses a lot of power just to run. So I'm going to set myself up a test here. I've got a nice RC meter that I'll hook in between the battery and the load. It'll have to have a auxiliary battery to operate it, or else it steals power from your battery. So hopefully I can run that test today if I can get this thing to come up to full charge. The solar panel is no longer getting direct sunlight, and it is a little bit overcast outside. I've got a meter right here that's measuring the battery. Actually right now the same thing as the charge controller is, And I've got a 5 amp blade fuse. Well, if you pull this fuse out, it connects the panel from the battery from the charge controller, and it'll give you an accurate reading of what the panel is giving you. Let's see if I can pull that thing. There we go. Look at that, 19 volts. That's pretty good. That is more than enough voltage to charge any 12 volt battery. The problem I have is I've only got one solar panel, and it's a 100-watt solar panel. And in maximum sunshine, I've seen this thing put out, even sitting here in my window, like 21.5 volts. Well, that's a lot of voltage, but the problem is I don't have the amps. I need a second grape solar panel just like this and put it in parallel with this one. That will double my amps but keep the voltage the same. And then if I get a third solar panel and connect it in parallel as well, then I triple my voltage. I get 3 times as much, no, I'm sorry, not voltage, amps. That's what I need. I need more amps. And then it would really start charging up any 12 volt battery. But unfortunately, this is all I have. I don't plan to buy another solar panel because I don't have no place to mount them outside. And they both have to be here in the window, and they're very expensive. So I just kind of have to work with what I got. So let's put our fuse back in here now and continue charging. And there we go. We go back down to the actual battery voltage. So maybe by later on this afternoon, I'll be able to start running this test, and I'll let this battery run the inverter all night long and see if it can power it up all night long. Well, I only got a little bit of daylight left, sun will be going down soon. So I decided to go ahead and start this test. I've disconnected my solar. I've connected up the Anself 300 watt inverter to the battery. It looks pretty archaic the way it is, but there is a 5 amp blade fuse in between there, so if something does go wrong, it is fused. So I've got my little RC meter connected up. It's showing 12.4 volts. Well, let's go ahead and just turn it on. We're not going to run the light bulb. We're just going to turn it on. And there it goes. You can hear the little fan running. Disconnect that. There's a little fan on this side, cooling fan. Well, let's see what we got here with the inverter running. Look at that, it's pulling 0.52 amps, about a half an amp, I guess. You see the reading on the lower left. It's using quite a bit of power. It's dropping my volts down. It looks like it's using 6.1 watts just to run that doggone thing. That's a lot. I can't imagine this battery's going to run for more than just a few hours. So. Well, it looks like I got about 6 hours out of my test last night. Somewhere between 6 and 7 hours. The inverter went into error mode. So it's currently showing almost 11 volts. Let's go ahead and turn the inverter back on and see what happens. There it goes. It's back on and running now. And it's still pulling just about 6 volts. It's dropping it down. I don't know if it dropped it down too far or what, but eventually it'll go into error mode, so I'm just going to leave it. I'm just going to let it run, and then we'll come back when it goes into error mode and we can see. And there we go, we're in error mode now. It didn't take very long. We have a red light on there It should have been just a green light when it was running, but the red light indicates error mode, and we have lost our, we're not pulling any more watts. So the fan is just running, but it's no longer functioning. So my conclusion is, for me, this AC inverter, DC to AC inverter, is just not going to work for me at all. I don't have enough battery there. Perhaps if I use one or even put two of these big lithium batteries together, I could maybe run a lamp like that for a while or something. But certainly with this small lead acid battery, it's not going to work. It consumes too much power. When that thing is taking away, as soon as you turn it on, and it's taking away 6 watts right off the get-go, that doesn't make any sense. It's only 300 watts anyway, so and it's loud. You can hear it. If you're in your house, using this, you're going to be listening to that. So I probably won't be doing any more experiments with this little gadget. All along I have decided to just kind of stick to DC stuff. So, well, we'll move on to another experiment in the very near future.